Hey everyone, welcome to another K6 Office Hours. I am Nicole Vanderhoeven,
And I'm Simme.
not Nicole this time.
No, not Nicole this time. Or maybe I am.
Oh no, the world isn't big enough for two of us. So we usually have guests on, and this is the point where we would usually introduce them. But today we didn't have anyone scheduled, and we actually thought that we should talk about something new that, well, I guess it's not really that new anymore. Simon, how long have you been working on this?
I think the project we're about to talk about has been around for about 6 months at the very least, maybe even more than that. And the topic that we're actually going to talk about today is the K6 operator. Um,
Oh, first we should do our announcements. Last
yes.
week we said that we were going to move in with Grafana. That's all happened and without too many issues. I will put a link to where the main K6 repo is now. It's on the Grafana one. But that's everything should work unless you are trying to like if you're trying to have a custom build of K6, all the vanity URLs and stuff will have changed. But most things should just redirect. So if you try and go to the K6IO repository, which we had just moved to a few weeks ago, that should still work. Things should be redirected.
Yeah.
Okay, so what else do we need to say? We need to talk about. Oh, I released a video a couple days ago about,
About
or
what?
earlier this week. Whoa, this is weird without a guest, huh? Let's just ask each other questions we already know the answer to. I mean, anyway, um, it was about GitHub Actions. So if you go and have a look in our channel, the last video is going to be about how to use K6 and in incorporating load testing to a CI/CD pipeline using GitHub Actions. So it's cool because it's something that I personally use for my site. So don't think that you have to be an enterprise paying for like expensive tooling to use it.
That's actually yet another community tool that I've written. But I guess you go through you go through both using the
Oh yeah.
official action and doing it manually. Or are you focusing on the action?
I think I focused on the action
Hmm.
because I just am going to use the way that is simplest.
Yeah, and that one is dead simple. I mean, you basically have to
I
add
didn't
like two
realize that you were the one that did that. I should have plugged you.
but it's
Next time I'm
hard
going
to
to
keep
use
track.
something that you didn't create.
Yeah. Like go out of your way to create something that I've
Yeah.
already done, but do it again just for the
No, no,
sake of not using
no.
it.
No. But yeah, you've created some awesome things for K6, so I keep naturally stumbling into them.
And this video is really good, so I recommend everyone that wants to do CI integration with GitHub Actions to have a look at that. And while we're on the topic of doing CI integrations, we also have pre-created or templated at least extensions for Azure pipelines and for Circle CI as well. So for at least
Yeah.
these three, you can use the official plugins that we provide.
Yeah, so in the video as well, because K6 is interoperable, you can use it with many other CI tools. So in that video, you know what? I'm just going to put a link to it here. But in that description, I also put a list of other tools that you could use K6 with and how to do that. We have Azure Pipelines, GitLab, Circle CI, Jenkins, in addition to GitHub Actions.
And just before we start having a look at the actual operator, I just want to take a moment to plug that next Friday, which will be the last episode that I'm on for a while, because I'm actually having a vacation this year. Who would have thought?
Yeah.
But in the next episode, we're having Marcus Olsson on, who is a developer advocate at Grafana, working exclusively with the developer experience of the Grafana plugin ecosystem. So if you're using Grafana or looking to use any visualization tool together with K6, make sure to tune in next Friday, because that's probably going to be really, really interesting.
I also just finished a tester's overview of Grafana Labs, is what I'm calling it, because I was honestly getting confused about all of the different products, projects, services that they've come up with. And now that we've joined Grafana Labs, I figure I should at least be able to tell people what these things are, if not be able to use them myself. So that's coming out probably on Monday.
Awesome.
Hey, when we don't have guests, we get the chance to like talk about what we're going to be doing. Oh, September. We do want to talk about that as well.
Yes. Go for it.
You go.
Okay, so in September we've been doing some live stream marketing, I guess, about the TestCon Europe that will take place in Lithuania, or would have taken place in Lithuania, because just a couple of days ago we unfortunately received news that they will be doing a online only conference this year, due to the somewhat shaky situation with COVID and the Delta virus and whatnot. So we were originally planning to have a full day workshop in performance testing that would have been with Grafana and K6 and other tools, as well as GitHub Actions, actually. But we've decided to cancel that workshop for now. So we're instead going to focus on making workshop content available for anyone who wants to do a K6 workshop, and not just the attendees of TestCon. But Nicole and I, or you and I, we will still be speaking at the conference, and I'll be speaking about observability and using K6 to do observability work in production. And you will be speaking about
Chaos engineering with K6 and Grafana.
And Pokemons.
And Pokemon. That's very important, especially since this week is actually a Go Fest that I'm taking part in. Okay. You always know how to derail me.
Yep.
With Pokemon. Okay. So let's talk about distributed testing. Why? What is
yes,
it again?
Naveen, it is a paid conference. I don't think it's super expensive, but it is paid. All right, sorry. So the operator, yeah, what is it? Let me share my screen. Bam. Okay, so operators, we are probably all of us are familiar with having operators at our workplace, mainly system operators, as in physical humans doing things in our environments, taking care of systems, making sure disks don't run full, or moving applications around to optimize performance, things like that. It's been around at least as long as I've been working in IT or in tech, and I assume it will stay around for the foreseeable future. But with Kubernetes, we want to automate this, or at least as part of our SRE efforts, we want to automate this. We want to apply the principles we already have for creating software to our operations activities as well. So what better way than to make a automation that acts as an operator? And that's exactly what K6 operators are. So let me just open some images, I thought, but it seems they've gone away.
So is this were you playing off, or is it related to Kubernetes operators?
Yes, it is. So Kubernetes operators are actually what the K6 operator is built on as well. So to be really transparent, we're building upon a project that's called the Operator Framework. And the Operator Framework is a system for building operators in Kubernetes in a as simple and cost efficient way as possible using some standards, right? So there are different ways to do this. There are different frameworks for it, but the one we've opted for, or rather that I've opted for, is the Operator Framework. And what this does in general in Kubernetes is that it adds the ability to uh, let you define custom resources in Kubernetes using their native state system, so to speak. So you can actually extend the Kubernetes object repository, like pods and config maps and volumes and things like that, with your own custom types that you can use to create whatever is relevant for the application that you are building. And for K6 in particular, we've been looking at having a community way to run distributed tests, or tests that span multiple load generators at least. Um, we already do this in K6 Cloud with great success, but we feel that it would be reasonable. It's a reasonable expectation that you'll be able to do this with the community version as well, especially as we pride ourselves on not providing a vastly different user experience depending on
Mhm.
whether you use the cloud or not. So enter
And
the
maybe we can
yeah.
sorry, maybe we can talk about why K6 Cloud might not be enough. One of the things that I think is first and foremost is that it costs. Sometimes you don't have the budget to pay for another service. It's also AWS only. So if you're an Azure shop or you use Google Cloud Platform, then that shuts you out. It's also our AWS account only. So you can't use your AWS account, and it also might have some security ramifications depending on the requirements for your organization.
Yeah, just to nuance that a little bit, because you are correct in that it's AWS and that it's our account. But I think for most shops, that is actually not an issue, or at least that's my impression, because whether or not the load that we are generating with K6 Cloud originates from within the same cloud provider or from AWS, for most shops, this is completely irrelevant, right? Because the latency between different cloud providers is so minuscule that even if there
Yeah,
are some additional latency, it's still low enough to be considered almost local
yeah.
network.
Well, what I mean is not so much the difference between the cloud providers, but if you're already paying for Azure, then it seems like it's doubling up on subscriptions if you're also paying to then have another bill for another cloud provider when you could just be using it wherever what even if you had an AWS subscription already. Like sometimes people want just like one bill, and that makes it easier to keep track of.
Yeah, sure. Maybe you're not looking to add K6 as an additional vendor, and
Yeah.
or a vendor that you're paying at least. And that makes sense for some. It has some drawbacks as well, of course, to not use the cloud and instead opt for using the operator. Uh, we're going to go into these a little bit more later, I think, but mainly you won't be able to, at this point at least, you won't be able to easily decide which geographical zones your traffic will originate from. You are able to do this, but it will require a lot of manual configuration to make sure that this happens. And the same goes for threshold calculation, and for instance, canceling tests once a threshold has been met. Currently, the operator will run a set of separate load generators, and if one of them fails their threshold, the other ones won't know that that has occurred. And in the same way, if the total of all load generators would pass a threshold, for instance, say that you only allow 5 errors as part of your test. Why you would choose 5, I don't know, but let's assume you did. And you have 5 load generators, then one of them, or rather, to fail, every single of them would have to have 5 fails. If they all have 4 fails each, which would sum up to 20 fails, you would still see that as a success, as they will be like evaluated individually. We have fixes to this on the roadmap, but it's not there, and we don't want to commit to when it will be there either at this point.
So let's a couple of comments here. One from James. There are situations where your testing needs to be on-prem, especially in financial institutions.
Definitely.
Yeah, anyone with like dealing with personally identifiable information that can't be cleaned, or you can't, if you have to use the actual data for whatever reason. It can be difficult to make the leap to cloud for security and legal reasons. You have to be able to make sure that that data is secure throughout the entire stack. And it's a lot harder when you don't control the infrastructure.
I would say I would still say that for 90%, or I'm just grabbing this out of air, but for 90% or so of all shops, this is not a requirement. And for them, it doesn't really matter where the traffic originates from. But for the 10% that has this requirement or this regulation, it's of course very critical. And in these cases, the operator is there to help you for sure, and might be an excellent alternative to running it on K6 Cloud currently.
I think there have been more and more security conscious organizations that I've run into more recently that have had it as a concern, not being able, like having to rely on somebody else's cloud. I mean, cloud is somebody else's computer, right? But but it is more difficult when you don't control it. Jose also points out latency is not an issue as volume is king, but depending on the volume, it can have a cost if it's not from the same Azure availability zone read outside the cloud provider.
Yeah, and that really makes sense. I mean, most cloud providers, I think AWS included, have an ingress and an egress cost attached to traffic going in and out of their networks. So if you are on the same provider, you're obviously not gonna accrue, I guess is the word, incur any of those costs. But if you go from Azure or from AWS to Azure, that might actually be an issue for sure.
Yeah.
I think these costs are quite small, even in the volumes we are talking about, but it's still something to take into consideration.
So when you, with K6 operator, question for you, this is distributed on cloud or on-prem, right?
It is not distributed in the cloud, if I understood the question correctly. That it's only for on-prem or for sort of say in your own hosted Kubernetes environment. So
okay.
you could use a managed Kubernetes provider and deploy the operator there for sure. And then it would technically be cloud, but it's not compatible with K6 Cloud at this point.
Oh, this is a good point from Hans. There's also testing of private APIs that might not be accessible externally or easily testable from another account. Yeah, I'd say this is probably actually the most common reason, right? Because yeah, there are things you can do. You can whitelist IP addresses or publicly expose. There are things you can do, but it can get complicated, and that can also require security approvals that you may not have time for.
Definitely. And while we're actually talking about Hans, I just want to make a shout out because he's been contributing a lot of code to the operator repo over the last
Oh,
couple
he's
of
that
months.
Hans.
Yeah, that's that, Hans. So thank you so much, Hans, for all your hard work. I think you really helped in getting the operator more stable and more of a mature or real project. So thank you a lot for that.
Awesome.
And
Have we sent
hope,
him swag?
yes, we have. I was just going to say,
Awesome.
I hope the swag has arrived, but if it hasn't, it should be with you within the next week or two.
Okay, so how do I use this thing?
Okay, so let's start by having a look at the operator model, just to make sure we understand what is going on here. So a Kubernetes operator is a set of different components that you have to use in your cluster. One of them being a controller, which is probably the main thing about an operator. So a controller is a process that you deploy in your cluster as a pod, and that controller will then listen to any events that occur to the state of your cluster. So in case someone applies a new manifest or someone creates a pod, deletes a pod, anything like that will be sort of looked at or evaluated by the operator. And we use this to trigger different types of events as things occur in the cluster. So we don't really interact directly with the controller or the operator, but we apply state configurations that will lead to the controller reacting in a certain way. So, for instance, we might have a Kubernetes object called a Pokemon. And when you apply that object to your Kubernetes cluster as a custom resource, then the operator will make sure that, okay, now we need to spin up a new whatever resource it might be for this Pokemon that we've applied. It might want to fetch an image and put that in a config map so you'll be able to look at how the Pokemon looks. Or something like that. It was a really bad example, but I'm sure you get the idea. And in the case of the K6 operator, what we do there is that we create a new custom resource called a K6 test. If I'm not mistaken, we have one here, so we can open it up. It's actually called just K6. Okay, so we create a custom resource called K6, and we set some metadata or some configuration to this custom resource. For instance, how many parallel jobs we want to split the load over. So say, for instance, that we want to do a test with 5 okay, for to make it easy, that we want to use 20 virtual users as part of our test, and that we want to distribute this test across 4 different load generators. Then the K6 operator will pick this up, look at the parallelism property, and see that, okay, for this test, we're going to distribute it across 4 different instances. It will split the amount of virtual users we have into chunks of 5, and then it will launch all of these generators in parallel, wait for them all to be ready to go, and then at the same time, or at the same time, start them and have them execute the test script. Does that make sense?
Yep, I'm with you so far.
And now we come to, okay, so once that's done, Once we've applied the CRD or the custom resource definition, the operator will look at that and act according to what we've added to the spec. It will create as many pods as we have specified in the parallelism property. Then it will create a starter job that will wait for these pods to be ready and then tell them to start. And then they will all execute at the same time. And when they are done, the job will shut down or the pod will shut down, and you will be able to have a look at the results created by each load generator. Of course, this might not be sufficient for all users. You might, for instance, want to output the metrics that you've created to a external system for easier visualization, for instance. Okay, so one question from Naveen Kumar.
Go on.
What if the VU count is less than the instance count? I think that might actually crash the operator. So that's actually something we should have a bug report for. I'm going to write that down and make sure to raise an issue to at least have a look at that, because that's not something that I've even taken into account. Good point, definitely.
Probably wouldn't be something that would come up a lot, though.
Yeah, and I guess it's kind of easy to tell what the issue is, because you might notice that you've created an impossible scenario. But in any case, it should probably not explode. It should just reduce the amount of instances.
A QA walks into a bar. That's funny.
What's the rest of that joke? It's like he orders a beer, minus one
beers, AD asterisk beers. Yeah.
And another question. So yes, result aggregation is in the roadmap, and I was just about to make a mention of that. So if you, for instance, have Grafana, shameless plug, then you can actually aggregate the results in your Grafana installation or in your dashboard. So just as you would with regular K6, where you add an argument saying, for instance, that, okay, I want to send all my metrics to Kafka in this case. You could do that for Grafana or for New Relic or for Datadog or what have you. So all of these will be able to ingest the metrics created by the operator, and then you'll be able to browse them just as you would regularly. Okay, so that's basically how the operator works. One thing that we can mention, or that we should mention at this point, is that to be able to run a script in for the operator to be able to run a script, you first need to make sure the script is available somewhere in Kubernetes. You can do this either by creating a config map and adding your test there, or you could do it by creating a volume in your Kubernetes cluster and place all your scripts there. So if you want to run, say, the same script across many different teams, you could have them stored in one place, and then each team will just point at whatever test they want to run at a certain point as part of their custom resource definition. All right, so let's go ahead and have a look at how this works in practice. And bear with me now, because the demo gods have been really kind to me the last year, so they might decide to strike at any point. Good thing we have Hans on the call, so if I run into any problems, he might be able to help me sort it out.
We should have asked him to actually come on.
Yeah, if you want to come on at some other office hours, Hans, you're more than welcome. Just reach out to me on Slack and we'll make that happen for sure. Okay, so we're going to start by installing. And what happens when we run the command install is that we apply the custom resource definition that we have to our cluster. So if we now do, if we now get all the custom resource definitions we have available in our cluster, we can see that K6 has been added to the bottom. And you can also see that in my lab environment, that is not the only custom resource definition that is available. So this is a common pattern used by most of the big Kubernetes projects. So now that we have the resource definition deployed, let's go ahead and deploy the operator as well. But just before we do that, we're going to make sure that the namespace that we're going to use is actually empty. So it is, and now we'll go ahead and deploy it. Okay, so you see this created a lot of different resources in the cluster. It also installed the custom resource definition, so you don't even have to run make install prior if you don't want to. I usually do that because then you can run the operator locally as well and not deploy it to Kubernetes. But that's completely optional. It creates a service account for the controller so that we know that the controller is contained in what it can perform on our cluster. So you won't have to worry about it wreaking havoc across other namespaces or just messing up your whole cluster. And there are some cluster rules and roles associated with that as well. It then creates a service for the controller and makes a deployment of it. So if we now check our deployments, we can see that we have an instance of the K6 operator here. That also has one pod. So if we get the pods, we can see that the pod is here as well. And actually it's two. Not sure why that happened. That shouldn't have happened. But let's, if that's all the demo gods have to throw at me at this demo, then I'm really content because that won't make any difference.
Can we blame Hans for it? He mentioned that he was worried that main wasn't working.
No, we can definitely not blame Hans. If anything, it's probably due to my my sloppy merging. But who knows? It could be my cluster as well. But it doesn't really matter. So that's totally fine. Okay, so we now have an operator in our K6 operator system namespace, and we have our custom resource definition deployed. Let's now have a look at the files that we can deploy. So we already had a look at the actual test job or test manifest that we're going to use to run this. But prior to that, we also need to deploy the config map that we'll be using. So, or the actual test that we'll be using. So the test that we will run looks like this. And as you can see, it's just a regular K6 test, but stored in a YAML body. If you have it lying around on your disk, you could create it using, I think, kubectl create config map, and then it's something like from file, followed by the file that you want to create a config map of. But it's usually easier to do it, or at least more consistent to do it this way. So let's have a look at the test script. We will run a ramp up to 200 virtual users for 30 seconds, and then we're going to ramp down again to 0 users for 30 seconds. And for this test, we're expecting that the failed request rate will be 0, which might be a bit optimistic, and that the HTTP rec duration will be below 500 ms. And then for our actual test function, we're just doing an HTTP GET against the Crocodile registry that we have available on our test API site. And we want the HTTP response status code to be 200. And if it isn't, we're going to increase the fail rate. This
Doesn't
speaks
that
to
happen automatically now, the fail rate?
yes.
Oh,
that's
is that what you were going to say?
yeah.
Sorry.
This speaks to how old this example is, or this demo is,
Oh.
because in recent K6 versions, this is kept track of automatically, so you don't have to do this additional check and this additional counter increment. But it will still work,
Sorry.
so let's keep it that way. So let's go ahead and apply this file. And if you're wondering about this K command that I'm using, it's just an alias for kubectl, so nothing fancy going on there, just an alias. And let's see. Okay, so the config map is created, and we can see that by getting our config maps. There it is. And we can have a look at it using the describe.
Sorry to interrupt you with a noob question.
Sure.
Can you explain again what a config map is? It seems like it is a way to be able to use the K6 script within this cluster. What exactly are you configuring?
Yeah, in this case, it's a way to host the script. You could do it on a volume as well, but due to how you really easily can copy files to and from Kubernetes using config maps, that's the original version that I wrote.
Mm-hmm.
But then Hans actually enhanced it by adding adding functionality for using volumes as well. So now if you have multiple scripts and you want to store them in the same place, then you can use that instead. It's probably
That's so good.
a better solution, but both works. So you can use whichever works best for you. And the config map itself is basically a key value store where the value is some kind of data that you want to make available to the pod that you're using it with. So in this case, I'm using it like a virtual file system, right? So we're storing test files in the config map. But it could have been anything else. It could have been a token, which is a common use case as well. It could have been configuration settings for an application or something like that. Or what have you. You can put it in there.
So would this not work on a Kubernetes cluster in the cloud, though?
It would, for sure.
Oh, okay. All right. So it would be able to do... No, sorry. Maybe I just didn't ask it clearly. But so it can do distributed load testing on the cloud or on-prem. It just depends on where your cluster is.
Yes. I interpreted your question as K6 cloud, where it can't be run currently.
All right.
But in the cloud, definitely. If you have a managed Kubernetes service somewhere that you're using, you'll be able to use this there as well. Unless they have a really, really tight security on your account, so you're not able to deploy it. But under regular circumstances, you would be able to, definitely. Okay, so now we have our config map in the cluster, and it looks exactly the same as the file I showed you above. So nothing fishy going on there. And I'll now go ahead and split my terminal in two, just so that we'll be able to see the logs of the operator as we perform tasks. So now we're getting into hard to see territory. I'll go ahead and zoom out one step, and Flor will have to squint to be able to see what I'm typing or what's on the screen. But I think it makes more sense. Okay, so here is the log of the operator. We can see that or the controller, that it started, it elected a leader amongst its instances or in this case, there were actually 2. So it has elected a leader out of those 2. And then we can see that it's started to listen to event sources. So if a event on a kind or a object kind called K6 is applied or manipulated in any way, the operator will pick that up and react to that. So now if we actually go ahead and apply the K6 manifest that I showed previously, some things are going to happen in our cluster. Let's see what is actually happening. I'm going to try to be quick here and show you what is happening when I use kubectl as well, just to give you a picture of how things progress. So, okay. Now you can see that 4 pods have been created. Now all 4 of them are running. And there is our starter pod as well. That will make sure they are all ready to start the test. That one has completed, meaning that they are now running the test. So if we have a look at instance number 1, we can see that a test is actually being executed in that pod. And the same goes for the others as well.
Nice.
So they've started at the same time, and hopefully they'll finish about the same as well in a minute or so. And we can, while we wait for that, we can have a look at what the operator actually did. So let's make that a bit bigger. We see that the controller started to create test jobs with the name K6 sample. And it then proceeded to launch the different load generators that we wanted. And then it considered itself done. So it created a new event that it pushed to the Kubernetes state, asking for a starter to be created. So the starter was created, and here we can see that it's waiting for pods to get ready. And we can see as they become ready in the logs as well. And once all 4 are ready, we can see that that message is also successfully reconciled. And the test starts. So I think our jobs should be done by now. Yep. So if we first have a look at the starter, we see that this is actually a really complicated. No, it's not. It's an implementation using curl that just checks the endpoints of the K6 API on each load generator, and once they all reply with a good enough status, it considers them all stable and starts the test. All right, let's see. Back to the pods. Let's have a look at the first pod. And if you've ever run K6 directly on your own CLI, you recognize this screen because this is the exact same output that you would get in the CLI if you were running it yourself. And here, if we would have set up an integration to, say, Grafana, we would have been able to watch all of these metrics together in a Grafana view. But I currently don't have any Grafana instance set up and configured for this. So let's pretend you see the Grafana dashboard and, oh, wow, all the metrics. Okay, so it's working. Yeah, and nothing failed, so everything is good there. We can see that our first load generator managed to cram in 1,377 requests during this minute, even with a sleep of 1. We can also see that if we check our test again, we wanted 200 VUs. And we can see from the result output that this one had a VU max of 50. So it has been assigned
Okay.
a fourth of the VU count. And the same goes for the others as well. About the same amount of requests and a VU max of 50. And that's basically it, right? So now our test run is done, and we'll be able to clean it up by deleting the custom resource that we've applied. And then everything except our operator controller is cleaned up as well. So we'll now be able to deploy another test and have that run instead.
We have a question from Arun. He's looking for distributed testing using AWS. Please let me know if you have any topics on it. Yeah, this is definitely something that you could use, as Jose said in the chat. You could use this K6 operator for that.
Definitely.
Or check out K6 Cloud.
Yeah, K6 Cloud if you don't want to do it yourself, and if you rather do it yourself, check out the operator. Jump on our Slack and join the operator channel, and there are plenty of people there willing to show you around and get you started.
So, question, what if a pod restarts mid-test, like if it becomes unhealthy? Will the test then also restart?
Currently not, no. So
That's probably a good thing.
Yeah, so in this case, if that happens, you will see that the status of that pod is probably exited, or that it exited with an error code, and then you can have a look at that and see what happened. But due to how resource intensive and how complicated test runs usually can be, and also, to be completely honest, due to the fact that I haven't had time for it, it's not actually recreating pods at this point.
But that's probably a good thing though, because if a pod becomes unhealthy because of a load test, then that might be because you're using up too much of the resources. So like there's no point in running it again and getting the same result.
Definitely.
And what if it was like a 3-hour test or something?
So let's have a look at the actual custom resource definition as well. Let's see. So, and this is a quite recent addition, but Hans actually added support for being able to add different properties that are available in the regular or the native Kubernetes objects as well. So if, for instance, you want to create a certain affinity rule for how your pods should be scheduled so that you don't risk completely maxing out a node, you can do that using the same rules as you would with a regular Kubernetes object. And I'm not completely sure, but I assume that anti-affinity would be possible as well. Yeah, it looks like it. So you'll be able to say like, okay, I don't want my jobs to run on the same, or my load generators to run on the same node. Pick a single node for each, a separate node for each load generator. And Kubernetes would go ahead and schedule it that way, which is really
this is such a different way of thinking about it, because now it's not load generation machines, it's load generator pods. I instinctively feel like if I were doing it this way, I would still just want the load generation pods to be running independently of anything else, just have some nodes that are set aside just for load generation. Am I being old fashioned there?
A little bit, I think, because you are able to apply resource limits and resource grants as the same way as you would with a virtual machine or with a pod of any kind. So say for instance that you want your load generators to have a certain amount of CPU, then you will be able
Mhm.
to say that to be considered an acceptable schedule, it must have access to these amount of dedicated resources, and you could do that just as with a separate virtual machine. You could say that, for instance, okay, I want this and this amount of CPU cycles to be dedicated to this pod. So then you would have that dedicated amount of cycles for your load generator, not risking it to interfere with be interfered with by other pods running on that node. And if it's unable to satisfy that, it won't schedule the pod on that node.
I guess I would have to run some tests to make sure that, a pod that's running on its own on one node without any other pods on it gets similar results to a pod that's running with 10 other pods and that collectively are using up 70% of the CPU. I would just want to have similar results.
Mhm.
And I know I haven't done those tests with K6, but I know like with functional testing tools, anything that has to do with the UI, basically the higher the CPU utilization, the larger the response time as well. So there is always an effect, even if it's like 2% versus 10%. There's an effect on that. So I don't know, maybe I'm just wanting it to be like absolutely clean, absolutely identical.
Yeah, and in that case, you would be able to say like, okay, for these jobs, I want them to have 100% of the CPU that is
Okay.
available. And then Kubernetes would have to find them nodes, or you would have to provide Kubernetes with nodes that
Yeah.
are completely clean. But you could also, which Hans is also, I think, kind of
Oh, the custom labels.
aiming
Yeah.
at, you could use node taints, for instance, and say like, okay, these two nodes will only get to hold K6 jobs. Or the only things that will be allowed to be scheduled there are pods that are tagged with the label or labeled with K6, for instance. And then any other pod that will try to schedule there will just be thrown out in favor of K6.
Okay. That makes sense. I might try this out.
You
I
should.
might bug you for questions, but I want to put this on my Pokemon Digital Ocean cluster.
Mhm. And one thing that I'd really like to have here that I think Hans, it's always Hans, right, has also solved is to be able to use custom K6 images for this. For instance, say that you want to do your
Mm,
chaos engineering, as I know you've been poking at for the last couple of months. Then you would be able to say like, okay, I have a Docker image that is placed in this registry, and it contains an XK6 build of K6 that also includes the chaos engineering extension. So you would have access to that whole tool set as well as part of your test.
wow. Wait, what? It's already in there? This is happening now? Are you telling me that I can run XK6 Chaos on the cloud?
Yes. I thought
What?
it was Hans who added that, but apparently it was someone else. So if someone else is listening, sorry, and make sure to remind me, and I will give you a shout out in the next episode for sure. But it is there. So if you create a Docker image that builds a custom bespoke K6 version using XK6, then you can utilize that as part of your operator as well, and run it with whatever you want to add. Say that you want XK6 notifications, maybe you want XK6 distributed tracing because you want to do tracing as well. Then you can actually add that already.
Wow. That's awesome.
I think so too. This is one of my favorite pet projects. So,
You
uh,
said that about XK6 Chaos.
yeah, one of my favorites. I have two.
Yeah.
So we are always looking for more contributors, of course. And Hans has been really kind and dedicated time to assisting with the project. But if any of you are interested in helping out and implementing more features, feel free to reach out to me on Slack, and I'll make sure to onboard you. But this was basically what I wanted to show for today. Let's, as the last thing we'll do, we'll just go ahead and actually. Oh, sorry, I need to actually check the make script. I think it's called delete. Yeah, let's go ahead and delete all the resources we've deployed. No, it's not delete. Wrong folder. There we go. And then it will clean itself up, and now we have no operator-related resources in our cluster anymore. But usually you don't do this. You just keep the operator around because there's no need to remove it. It doesn't use that much memory or CPU if there are no events. So you could just keep it there between runs.
Okay, that's awesome. What are the things that you would like to work on? Because I'm thinking, we should promote this for Hacktoberfest in particular. This might even be more interesting than XK6 Chaos.
Yeah, definitely. And one of the things that I would really like to do is to add support for syncing threshold fulfillment between load generators. That would be really cool. Exactly how that will work, not sure, but that would be so cool.
And why is it Kubernetes only?
Because to be able to run distributed tests, you kind of have to have a distributed container solution as well. So it made sense to use Kubernetes. It should, of course, be possible to use it in Docker Swarm or something like that as well. But the tooling around Docker Swarm just isn't as fully featured as the one in Kubernetes. So I think most are moving towards Kubernetes for distributed containers anyway. So we went with Kubernetes. But if you, who is watching this, have a different approach that you think would be even better than using Kubernetes, let me know, and we'll reconsider or launch another cool project like this.
I think the results aggregation, I thought it was a big deal, but if you can do it with some other visualization tool, then I don't think it is a big deal then, because you wouldn't be looking at logs to get your results anyway.
One thing that would be cool to support is to actually be able to send your logs to K6 Cloud and have them presented as one test. You can currently send them to K6 Cloud, but each load generator will create a separate test run. So that's currently not possible, but that would be really cool because there are some killer features in the Cloud UI, like the performance insights and things like that I really would like to allow users to leverage as well.
Yeah, and comparisons as well. But some of that you can set. Well, you can't set up insights, but I think that if you had like a nice dashboard set up for you in New Relic or Grafana already, then you could just use that.
Sure.
But yeah, it would be cool. And then you were saying that it's difficult to choose geographical zones?
Yeah, it could be, right? Because then you have to work with different labels or different affinity rules to make sure that they are actually spread across those zones. So it's not as easy as in K6 Cloud, where you just say, okay, I want 50% of the load to be from Oregon or whatever you might decide on, and 50% to be from Berlin. That's obviously a bit harder if you do it yourself.
Could you just set up separate? No. How? Yeah, that would be a little tricky.
You would probably set up cluster nodes in each geographical region and have them be part of the same cluster, and then you would use affinity rules to decide which should go to what node, right? In that way,
Oh,
you would be
okay.
able to spread them across a larger geographic zone. But that is a bit more involved, for sure,
Yeah.
than just doing it in the cloud.
Okay. Well, thank you for showing me that. I haven't seen it before. You've talked about it, but I've never actually looked at it. So I will use it and I'll let you know how I go, especially if I get stuck somewhere.
Thank you for actually suffering through a whole hour of me talking about it.
No, it was great. It's something I want to use. So
And I think we are out of time, actually.
right
Uh,
on schedule.
yep. One thing that we need to add before we end this stream, as always, we are hiring. So if you want to work with us, or if you want to work with the cool people in the bigger Grafana organization, make sure to check out both sites, and you can see what kind of career opportunities we have available there.
Nice feedback there from Sass Silverine.
Thank you so much. Glad you enjoyed it.
All right. Thank you, everybody, for listening. Thank you, Sima, for sharing and showing yours and Hans' Next and somebody else's awesome work. Have a good weekend, everybody.
Have a good weekend, and thank you.
Bye.